So what's up guys, and welcome to this video. And on today's video we're going to go over some questions regarding the tangent and the normals. So here we have the question: we need to find the coordinates of the point where the tangent to the curve y is equal to x squared plus 1 at the point 2,5 meets the normal to the same curve at the point 1, 2. So there's a lot going on in this question. It can be kind of confusing, but effectively what we need to do is we have to find out the equation of the tangent, and then we have to find out the equation of the normal. And then once we find out both those equations, we need to equal them together because both of them intersect at another point, and we need to figure out what that point is. So to work at this question, we first are going to work out the equation of the tangent first, okay? So let's work out the equation of the tangent. So work out the equation of the tangent is fairly simple here. We have our x value as 2. We just write our x value as 2. We have our y value as 5, but we need to work out our m value here. So to do that, we just need to differentiate. So if we differentiate x squared plus 1, then dy over dx is just simply going to be 2x, okay? And then that means that 2 times 2 is 4. So we know that our m value is going to be 4, okay? And now that we know that, we can put that into the equation of a straight line formula. So y take away y1 is equal to m times x take away x1. So we have y minus 5, that is equal to, not 2, that is equal to 4 times x minus 2. And then that would be y is equal to 4x minus 8 plus 5. So y is equal to 4x minus 3. Okay, so we've worked out what our equation of the tangent is. So for the normal, working out the equation of the normal, all we need to do is, again, we know that if we were to differentiate x squared plus 1, we would get 2x. But now, instead of putting 2 in, we want to put 1 in because it's at the point 1, 2. So m would be 2 times 1. So we know that our gradient at that point is 2. However, it's asking for the normal, which means that we need to look at the perpendicular gradient. So let's say the perpendicular gradient is n, then we know that it has to be minus a half. Remember that the normal, it has a perpendicular gradient, and to look at the perpendicular gradient, you just do the negative reciprocal on your gradient. So we have 2, so imagine it was a fraction, imagine it was 2 over 1, then the negative reciprocal of that is just going to be minus 1 over 2, okay? We just flip the fraction, okay? So now for this question, we have n as minus a half, we have x as 1, and we have y as 2. Now again, we just work out the graph, the equation. So that'll be y take away 2 is equal to minus a half of x take away 1. And if you do that, you will get y is equal to minus a half x plus a half. And I'm going to plus that 2 over to this side, which will give us a 4 over 2. I'm writing it as a fraction to make it easier to add later. And then if we simplify that down, we get minus a half x plus 5 over 2. Okay? Okay, so these are both the equations. So we know the equation of the tangent is y is equal to 4x minus 3. And we know the equation of the normal is y is equal to minus a half x plus 5 over 2. So now we need to work out the coordinates. We need to work out the coordinates of that point where the tangent and the normal intersect. So to do that, it will be simultaneous equations. So that's pretty easy to work out. All we need to do is make our equations equal to each other. And because they are both y equals something, we can just put them equal to each other straight away. So if we do that, it would just be 4x minus 3 is equal to minus a half x plus 5 over 2, and then we can just solve for x. So if we do that, we will get 4x, we will get 4x plus a half, and that is equal to 3 plus 5 over 2. And then if we just rewrite this, so this would be 8 over 2x plus, oh, I forgot my x here, plus a half x, and that would be 6 over 2 plus 5 over 2. So then that would be 9 over 2x. That is equal to 11 over 2. So now that we have this, then it's very simple. We can just do 11 over 2 divided by 9. So x is 11 over 2 divided by 9 over 2. And I'm just going to, even though I know what it is, I'm just going to show you a way just to do it. If you're unsure, we can just flip the fractions. So 11 over 2 times 2 over 9. Then the 2's will just simply cancel out. And we're just left with 11 over 9. So we know x is 11 over 9. And then now all we need to do, we'll scroll down. All we need to do is, now that we know x is 11 over 9, we just need to put the x value into any part of the equation. So let's use the y is equal to 4x minus 3. So if we use the y is equal to 4x minus 3, then we can look at our y value. So y is equal to 4 times 11 over 9 minus 3. Scroll down now. And that will be 44 over 9 minus 3. And then that is 44 over 9. We're going to write 3 as a fraction, which is minus 27 over 9, which is 17 over 9. So we know that our coordinates will be 11 over 9, 17 over 9. So it's not the most nice number, but this is what it would be. There are loads of other ways you can write this too. I'm just going to leave it as an improper fraction like this. So our answer is 11 over 9, 17 over 9. Those are the coordinates where the tangent and the normal meet. Okay, so we have this question now. We have the point P with x coordinate a half. It lies on the curve of equation y is equal to 2x squared. The normal to the curve at P intersects the curve at points P and Q. We need to find the coordinates of Q. So again, there's a lot to digest in this question. This is an exam style question as well, so you could get on your exam. So with these type of questions, what you need to do is really think about what it's asking you to do. So it says that the normal to the curve at P intersects the curve at points P and Q. So when it says the word intersect, okay, when it says the word intersect, okay, this word here is key. What this tells us effectively, when it says intersect, it usually means that you're most likely going to have to use some form of simultaneous equations, okay? So you're going to have two sets of equations. Now we need to figure out what are those two sets of equations, okay? So in this question, it's the normal intersects the curve. So the normal intersects the curve. So we know that if we have an equation for the normal and we have an equation for the curve, we're going to need to put them two together, okay? And that is all we need to do. And we find the coordinates of Q, okay? So what that means is when it intersects the curve, it's going to hit at 2 points. However, we do know that one of our points, it already tells us that x will be a half, okay? So when we do simultaneous equations, we should get 2 points for x. One of them should be a half, and the other one is an unknown, which we don't know yet. That is the one we need to figure out. So let's go through this question. So first things first, okay, we have a point P with x coordinate a half. It lies on the curve. So first things first, we need to work out what this normal is to the curve at P. So to work that out, we need to know our x value. Our x value is a half. Okay. We don't know our y value yet. Our y value is an unknown. We don't know what our gradient is. And we also need to work out the perpendicular gradient, okay? So there are 3 unknown values we need to work out in order to work out the equation of the normal. So first things first, let's work out our y value, okay? So our y value is very simple. All we need to do to work out our y value is where we have y is equal to 2x squared, just substitute in a half. So if we do that, we get 2 times a half squared, which is 2 times 1 over 4, which is 2 over 4, which is a half, okay? So we know that y is a half. So on this curve, we know that when x is a half, y is also a half, okay? Then we need to work out our m value now. Okay, so our m value is, talk about our gradient, we need to differentiate and then plug in our x value. So if we do that here, we will have that dy over dx of 2x squared is just simply going to be 4x. Okay, so if y is 2x squared, we know that dy over dx is just going to be 4x. And then we substitute in our x value to work out our m value. So that will be 4 times a half. So we have our m value as 2. Okay, our m value is just 2. So we know that our gradient is just 2. However, we want to work out the normal. So it's a perpendicular gradient, which means that our perpendicular gradient is minus a half. Okay? Okay, so now that we've worked out all those values, let's put it into this equation to work out the equation of the normal. So it's y take away a half is equal to minus a half x minus a half, which is, that will be y take away a half is equal to minus a half x plus a quarter. If I just scroll down a bit, that means that we will have y is equal to minus a half x plus 1 over 4. And if we're going to plus a half, then what we need to do is we're going to change that into a fraction, or a different fraction, to add them together. So 2 over 4, 1 over 2 becomes 2 over 4. So now we get that y is equal to minus a half x plus 3 over 4. Okay, so now that we have the equation of the normal, we know that the equation of the normal is y is equal to a half x plus 3 over 4. Now, remember when I said about the intersection, we know the normal intersects the curve at points P and Q. So if we have that, so we know that the curve is y is equal to 2x squared, and then we have the normal as y equals a half x plus 3 over 4. What that means is we need to make them equal to each other. So if we make them equal to each other, then what that will be is that will be 2x squared is equal to a half x plus 3 over 4. And you may already see what's going to happen when we solve this, or when we put everything to one side. Let's bring everything to the left side. So it'll be 2x squared plus a half x minus 3 over 4, and that is equal to 0. And now we have a quadratic equation which we need to solve. Okay, so now we need to solve this quadratic equation. Now, if you have a calculator, if this is on a calculator exam, then feel free to use your calculator, put this into your calculator, and it will give you your solutions. However, let's say it's on a non-calculator exam, I'm going to just solve it by hand. So first thing first, what I would do is I would times everything by 4 just to get rid of that fraction. So you times everything by 4, you get 8x squared plus 2x minus 3, and that is equal to 0. Now, there are two ways you can solve this. I mean, actually, there are loads of ways you can solve this. It's really up to you how you solve it. You can use the quadratic formula. You can complete the square, but there's an easier method. I'm not entirely sure on the exact name of this method, but effectively what we can do is we can do 8 times 3 here. 8 times 3 gives us a minus 24. And then if we just think of two numbers which can sum to make 2 and times to make minus 24, that would be a 6x. And that would be a minus 4x, okay? And then we can just factorize these separately, okay? So we now have 8x squared plus 6x, and we now have minus 4x minus 3, and now we can just factorize these separately. So if we do that, what are common factors of this? 2 and x are common factors. So 2x, we are left with 4x plus 3. And then with minus 4x minus 3, again, 4x plus 3 would be in the brackets. And we're just left with minus 1 on the outside. So what that means is that if we were to factorize that, it would be 2x minus 1, 4x plus 3. Okay? And that is equal to 0. So now what we've done is we've factorized this. And now all we need to do is solve it now for x. So you can maybe see now what's going to happen. If we do 2x minus 1 is equal to 0, x will be a half. And we will also have x is equal to minus 3 over 4. Okay, so now we've got our values of x is equal to a half and x is equal to 3/4. So if we go back to the question, we know that the point P has x coordinate a half. So we know that when we have x equal to a half in our answer, we know that relates to point P, because it does tell us that the normal to the curve intersects at points P and Q. P being when x is equal to a half, which is good. We want to get x equal to a half because that tells us that we're on the right tracks, we've done the right thing, and it's now the other x, that's what we care about. That is going to be the coordinates of point Q. So if we have that x is equal to minus 3/4, then all we need to do now is we need to work out our x value. So on the curve, we know that the equation of the curve is y is equal to 2x squared, as they tell us in the question. All we need to do now is plug in our x value, which is minus 3/4, and that should give us our y value. So if we do that, we get y is equal to 2 times minus 3 over 4 squared, which if we work that, that's 2 times, so minus 3 over 4 times minus 3 over 4 is a positive 9 over, not 8, 16. And then that will be 18 over 16. And if we simplify this down, that will be both of them going to 2. So that will be 9 divided by 8. Okay? And therefore, that we know that Q, so it asks us to find the coordinates Q. We know that Q is at the point of minus 3 over 4, 9 over 8. So that is the coordinates of Q. For this question, it is long, but there's certain words you got to realize when it says intersect, you know you're going to do some sort of simple equations. What does it want you to intersect? In this question, it wants you to work out the equation of the normal, and that intersects with the curve. We already know what the equation of the curve is, so we need to work out the equation of the normal. And once we work out the equation normal, we just equal them to each other to work out our x value. And we should have two x values. As we do, we get a quadratic equation, and then one of them should be at point P. So one of our x values should be a half, which we do get. And because we get a half, we know that we are on the right lines. And then from there, it should be nice to work out. But yeah, that will be it for this question. I hope you enjoyed this video, and I will see you soon.